When we talk climate, carbon often comes in as the villain. We think of excessive CO2 emissions that clog up our atmosphere and warm the planet. While that's all true, there are some spaces where we actually want to see more carbon, where it's sequestered underground and away from our airways. A great place to see this in action is around where the land meets the sea. Let's dig a little deeper. All along global coastlines, just a little below the surface, you can find blue carbon. No, it's not literally blue, but we call it that because of the role that marine ecosystems play in dissolving CO2 and locking it in sediments beneath the ground. Coastal wetlands are particularly good at this. Sinkholes, seagrasses, marshes, and at the top of the podium, mangroves. These environments are already incredibly important to our coasts. So being essentially carbon-storing machines really puts the cherry on top of this ecosystem service sundae. This makes it all the more serious that mangroves are decreasing on a global scale. There's so much at stake here, from the communities that rely on them to the state of the global climate. Estimating how much carbon specific areas store is one important piece of the puzzle in preserving these coastal protectors. Now, blue carbon quantification is no walk in the park. It's more like a trudge in the mud. For the best estimates, you have to go deep into different forests and take sediment samples from cores that stick meters into the ground. Have fun trying not to get stuck on any roots. Then you bring it all back to the lab for processing. Section out your cores by depth, then stick them in drying ovens. You don't want your samples all sloppy. You weigh them out, and then
you take out your rage about mangrove degradation. You subject them to sizzling acid, and you throw them into the inferno to incinerate them into smithereens.
Homogenize your samples, test for inorganic carbonates, and find the loss on ignition. Lastly, do tiny tinfoil origami to pack a little bit of each sample for the elemental analyzer. With all your measurements, you can calculate the total organic carbon for each sample, sum it up for the core, then average it across an entire country for a national carbon stock estimate. These numbers mean a lot. When we know how much carbon different types of ecosystems store, we can write evidence-informed policies to protect these ecosystems. It's also really important to involve the people who live around these coastal wetlands in the science and decisions that will first and foremost impact them. So there you have it. Sometimes finding more carbon actually means less climate change. If we couple nurturing our blue carbon landscapes with reducing greenhouse gas emissions, we can save our mangroves and help the entire world.